Yeah, welcome back, friends. Now let's take up a very important and very interesting chapter of our visualizing solid shapes. We are going to learn about the faces, the edges, and the vertices of solid figures. Now, when you look at this solid figure, right, you see this solid figure is called a cube. Let's take another pic. See this pic. Right, this is a cube. This cube we can divide into three parts. See, we have the edges, the faces, and the vertex. The edges I'm going to do as red. Okay, so look at this. This is the edge. This is an edge of the cube. The face is what you can see. Like in this picture, the red part you see, the yellow part you see, the blue part you see is nothing but a face. So the flat figure is a face, right? So a face is the flat surface. And let's take the vertex in green. The vertexes are these points. So the sharp point we can see here is the vertex. See, these sharp points are the vertexes. So we have face, the flat surface, the edge where the two faces meet. Let's see, an edge will be where two faces meet, and a vertex will be where three faces meet. See, that's very important to understand. See, look at this vertex. This vertex, if I take out, let's say I'm drawing the face as yellow. So see, this first face, this face, right? This face we can see. The second face at the back, right? And the third face on top. The three faces are meeting at this point, which is the vertex. Right? So three faces meet at a vertex. Two faces meet, that's the edge. So edge is normally a line segment. Right? An edge is normally a line segment. You'll see this red part is a line segment. And a vertex is normally a point. Okay? So a vertex is a point, an edge is a line segment. Now a riddle is there. The question is, I have no vertexes. Yeah, I have no vertices. I have no flat face. So who am I? I would think it's a sphere, right? A sphere, a ball, has only curved surfaces, right? No flat face and no vertices, no point, right? Okay. Now this figure is a cuboid. This is a prism. Right? This is a pyramid. Now you see the difference between prism and pyramid. In a prism, that we have a rectangular faces and triangular faces. In a pyramid, we have a rectangular face and triangular face, same thing, but you see they meet at one point. So we have a vertex also here. Right? Then this is a cuboid and a pyramid together. So it's right. We can call it a polyhedron. This also is a cuboid, cube, but a little bit. It's not regular. You see, it's broken up here, or it's this part is cut off. So all these solids are made up of polygonal regions, which are called its faces. Right? The polygon region, like this part, is a face. The flat part is the face. These faces meet at edges. See, the faces will meet at edges. So in this case, the edge up here is there. This is the edge. This also is an edge. And edges are line segments, right? See, edges are line segments. And the edges, we can say, meet at vertices, or the three faces meet at vertices, or the edges also meet at the vertices. So we take edges meet at vertices, and which are points. So we have faces, flat figures, flat surfaces. Faces meet at edges. Edges are line segments, and edges meet at vertices. which are points. Okay, such solids are called polyhedrons. Right? Polyhedrons. Remember this, right? So polyhedrons have flat faces, have edges and vertices. Okay. Now look at, so see, cuboid, a prism, a pyramid, and a type of cuboid only, they are polyhedrons. But look at these surfaces. Right? So you can, this is a rectangular prism. Then look at these figures. They are not polyhedrons. Why? You see, they have something special, something different. They have curved surfaces. Right? Let's write them. See this. Look at this sphere. This sphere has a curved surface. See, the surface is curved. The cone also has a curved surface, but we call it a lateral surface. So a curved surface or a lateral surface mean the same thing. It is not flat, it is curved. Okay, a cylinder also has a lateral surface. So a cone, you see, has a curved surface, there's a lateral surface. It has a plane base, base which is a flat surface, and it has one vertex up here. A cylinder, you see, has no vertices. It has two flat surfaces, two bases, and one lateral surface, but it will have an edge. This line, this circle, is an edge. So you'll see there's two edges, right? One here and one here. While the cone will have only one edge up here only. Sphere has no edges, no faces, only a curved surface, right? So this is what we are going to study right now after some time. Now we have convex polyhedron and we have concave polyhedrons. Okay. Convex polyhedron all opens outside only. See, look at this cube, look at this hexagon, polyhedron. They all open outside. While a concave polyhedron will go inside. There are some, हम बोल रहे हैं गुजराती में खांचा हो, यानी हिंदी में खांचे होते, गैप्स होते. Like see in this star, you see it goes inside also. Now let's talk about regular polyhedron. When I say regular, it means all the sides are equal. Yeah, a polyhedron is said to be regular if its faces are made up of regular polygons. So equal sides, right? The equal sides. Regular polygon means equal measure, equal side measures, and the same number of faces meet at each vertex. You see in this figure, at this vertex 3 faces are meeting, at this vertex also 3 faces are meeting. So same number of faces meet at each vertex. So it's called a regular polyhedron. So this polyhedron is regular. Why? See, first thing, its faces are congruent. All the faces are congruent. They are regular polygons. Vertices are formed by the same number of faces. See, the vertex up here is formed by 3 faces. This polyhedron is not regular. Though the sides are congruent, all the 6 sides of this polyhedron are congruent, but vertices are not formed by the same number of faces. You see up here at point A we have 3 faces only, and at point B we have 4 faces. You see at point B 1, 2, 3, 4, and at point A 1, 2, and at the back 3. So it's not a regular polyhedron. This is a regular polyhedron. So 2 important members of the polyhedron family are prisms and pyramids. Difference in both is that a prism would have, say, rectangular faces and triangular faces, or all of them would be rectangular faces. There are no sharp points, right? In a prism we have base would be rectangle. In a pyramid the base is a rectangle or a triangle, and the top part is a pointed structure. See, it meets at a vertex. Right? Up here you see there's no it doesn't meet at a vertex. So a prism is a polyhedron whose base and top are congruent polygons. See, the base and the top are congruent polygons. See, up here the base and the top are congruent polygons, and whose other faces, lateral faces, are parallelograms in shape. See, the other faces are parallelograms. Pyramid is a polyhedron whose base is a polygon. See, the base is a polygon of any number of sides. It can be 3 sides like this figure, it can be 4 sides like this figure, whose lateral faces are triangles. See, lateral face will be triangle only with a common vertex, meaning if you join all the corner of a polygon to a point not in its plane, you get a model for pyramid. So a prism or a pyramid is named after base, right? It is named after base. Like this is a rectangular prism. This is a triangular prism. This is a rectangular pyramid. This is a triangular pyramid, right? So we have a triangular pyramid, hexagonal pyramid, rectangular pyramid, right, etc. We name it after the base. So a square pyramid has square at the bases, right? Square at the base. Got it now? And the top would be triangles meeting at the vertex. So now we are going to see different figures: a cuboid, a pyramid, a triangular prism, a pyramid with square base, and a prism with square base. And we are going to find out the face, vertex, the edges, face plus vertex, and edge plus 2. Right? This formula we are going to make. Now see. Let's draw a cuboid first. So I'm going to draw it up here. I'm going to try to draw as much as possible. Let's see how it turns out. Okay, now this is a cuboid. How many faces does this cuboid have? Let's take another color. Let's take, see, faces 1, 2 at the back, 3, 4. Right? See, sides. And then 5 and 6. So it has 6 faces. You see, 4 lateral and 1 top and bottom. 6 faces. How many vertices will it have? So vertex would be the points, right? So 1, 2, 3, 4 at the top, and similarly 4 at the bottom. So 8 vertices. And how many edges will we have? So how many line segments are formed? You see. So 1, 2. Same way 3, 4. Right? Same way 5, 6, 7, 8, and 9, 10, 11, 12. So it has 12 edges. You try on your own. Take a box and see how it looks. Now let's calculate. Face plus edge. Face plus vertex, 6 plus 8. That is 14. And edge plus 2, 12 plus 2, 14. This always will be equal. Now let's take a triangular pyramid. So I'm rubbing this out. Let's take the second part. We have a triangular pyramid, meaning, friends, a base will be a triangle. The base is a triangle, and the top also will be a pyramid, a triangular part, like this, right? Okay, now look at the, let's see the faces. How many faces will this have? So you see 1, 2, 3 at the back, and 4. So 4 faces. How many vertices? How many sharp points? So 1 and 3 at the bottom. So 4. And how many edges will it have? So you see 1, 2, 3 yellow lines and 3 green lines. So total 6 edges. See, 4 plus 4 is 8, and 6 and 2 is 8. Again equal. Let's talk about triangular prism now. So let's rub this out. Let's take a triangular prism. So in a triangular prism, we have the base and the top. Both are this is a triangular prism. Now look at this figure now. How many faces will it have? The faces means this part. Now 1, 2, 3 at the back, 4 and 5, the top and bottom. So it has 5 faces. Right? Think of how many edges will it have now? Sorry. 5 faces. How many vertices will it have? How many sharp points? So 1, 2, 3 at top and 3 at the bottom. So 6. How many edges will it have? So see, 3 up here at the top, 3 at the bottom, and 3 in the side. So again 9. Let's add out 5 plus 6, 11. 9 plus 2, 11. Same, yeah, we are right. Our answer is right. See, if these two become equal, this formula, then we know our answer is right. So I have a triangular prism. Now I have a next figure. We have a pyramid with a square base. Pyramid, square base. How will it be? Okay, we have a square base. So let's take square base, and then let's draw the pyramid. So pyramid means sharp edge, na? Okay, pyramid with the square base. Again, let's find the faces. How many faces? So see, because it has 4 sides. So 1, 2, 3, 4. 4 triangles, and the 5th base is square. So 4 triangles and 1 base. So we have 5 faces. What about the vertices? How many sharp points? So 5. You see, the square has 4 sharp ends and the pyramid at top. So again 5. And how many edges? So you see, again at top we have 4 and 4 at the bottom. So we have 8. Let's calculate. 5 plus 5, 10. 8 plus 2, 10. We are correct. Our diagram is right. Now let's take a prism with a square base. Okay, so we have now a prism with a square base. So a prism will have, let's say, a square top, down, 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 and a square bottom, like this, right, friends? This is the figure. So again, look at the faces. How many faces will this have? So 4 at the cross. See, 1, 2, 3, 4, and then top and bottom. So 6 faces. See, a cuboid and a prism with a square base are one of the same, friends. You see. So 6. How many vertices? So 4 at the top and 4 at the bottom. So 8. How many edges? So we have 4 at the top, 4 at the bottom, and 4 in the side. 12. Now you can see 6 plus 8, 14. 12 plus 2, 14. Same thing. So based on this, we get this formula. Right? Face plus vertices is equal to edge plus 2. Right? Face plus vertices is equal to edge plus 2. This formula is called Euler's formula. Euler's formula. And this formula is true for any polyhedron. Right? So now once you can calculate this, you can always get whether you are right or wrong. If this doesn't match up, your answer is wrong. Now, guys, you are smart enough, I'm sure, you can practice exercise 10.3 on your own. Right? So now think of these questions and try to answer these questions, right? Okay? Just try and verify this. That's it. Chapter over. Okay? Fine. I hope you understood the chapter. I hope you liked the explanation. Any doubts? Please contact your teacher. Okay. Bye, friends.